Howdy, howdy, howdy. We're talking interior angles. And before we use this beautiful website, let's go back to our booklet. We're going to skip all the way to lesson 4. And we're going to speed run this because your time is valuable. So lesson 4 is all about not only understanding what interior angles are and not only measuring those angles, but understanding the sum of those angles within a triangle and within a quadrilateral. Please remember that sum means the answer for an addition question. So 2 plus 3 is the sum of 2 plus 3 is 5. Okay, cool. Interior angle, we're referring to the angles on the inside of the shape, not the angle on the outside. We're talking angle on the inside. Interior means inside. Cool. What we're going to look at are triangles and quadrilaterals. Remember, the quadrilaterals are any shape that has 1, 2, 3, 4 sides and 1, 2, 3, 4 vertices. This parallelogram is also a quadrilateral because it has 1, 2, 3, 4 sides. Believe it or not, this weird looking shape is a quadrilateral. 1, 2, 3, 4 sides and 1, 2, 3, 4 vertices. Quadrilateral. Cool. So now that we've got that terminology out of the way, what the heck are we talking about? Well, if you take the time to measure the interior angle of all of these shapes, you're going to find something that's really interesting with their sum. So this one, they gave us the angles, so that's nice. Let's go ahead and do that right now. Let's find the sum of all 3 angles. So we've got 80 plus 70 plus 30 down there. Cool. That's supposed to be a 3, pardon me. Zeros will add up to 0. 8 plus 7 is 15. 15 plus 3 is 18. Cool. So the sum of all 3 angles in that triangle is 180 degrees. Interesting. Okay. Might not be important. Might be. I don't know. Let's find out later. If you took your protractor and measured the angles of this triangle, well, firstly, you wouldn't need to measure this one, would you? Because we already know that this is 90. It's got that little square arc, and that square tells us that it's a right angle, a 90-degree angle. Cool, so that's out of the way, done. But if you took a protractor and measured this angle, you would find that it's 60 degrees. Okay. And if you took another measurement of this last remaining angle, you would find that it's 30. You might be thinking like, well, Lewis, how do you know that? Well, I have measured these. And if you don't trust me, measure it yourself. Prove me wrong. Okay, so let's find the sum of these 3 interior angles. Okay, 30. You're probably already streaming at the screen because you know it, because you've done your mental math. That's awesome. If you didn't, that's okay. We'll do it right now together. 30 plus 60 plus 90. Sorry about my bad printing. Zeros will add up to zeros. 3 plus 6 is 9. 9 plus 9 is 18. So the sum of this triangle is also 180 degrees. Is that a coincidence? Did that just happen on chance? Well, the answer is no. This is something that we're going to be looking at for the rest of your math career, is that the sum of the interior angles of every single triangle in existence, every single triangle in the universe, that sum always adds up to 180, which I think is really cool. And why is that useful? Why do we need to know that? Well, sometimes you're going to come across questions where they say, hey, this angle is 90 degrees, and this angle is 60 degrees. Solve for n. What angle would n be? And they'll say, sorry, you can't use your protractor. Well, how the heck could we figure this out? Well, if we know that all 3 angles add up to 180, I can just work backwards. Instead of adding these things up, I can just subtract them. So check this out. 180 take away 90. Yep, of course that is 90. Because 18 take away 9 is 9. 180 take away 90 is 90. Cool. Now I'll subtract the 60. 90 take away 60 is 30. So now I just found out what n is. N is equal to 30 degrees. And I did that without having to bother with my protractor. I just used math and my knowledge that the sum of the interior angles adds up to 180 in triangles. Pretty nifty. Will that work in a quadrilateral? Well, let's find out. This shape, it didn't give us the numbers for the degrees, but we don't need them. We see these square angles. Those little square arcs tell us it is a square angle or a right angle, or in other words, 90 degrees. So we've got 1, 2, 3, 4. We've got 4 90s. So I could go 90 plus 90 plus 90 plus 90, but no thanks. That's a waste of my time. It's a waste of your time. Let's multiply it. 4 times 0 is 0. 4 times 9 is 36. So this square, its sum of its interior angles is 360 degrees. Interesting. Now this parallelogram down here, I have already measured it. D and B, they are both 109 degrees. Same with this guy, cool. And A and C, they are both 71 degrees. I don't know. Will that add up to 360? Just like the square? I don't know. Let's find out. I'm going to go up here. I'll change my color just so it's easier to see. Okay, so let's go 109 plus 71. We'll just add up two angles just to start because these are kind of weird numbers. Let's see what this gives us. 9 plus 1 is 10. I'll carry the 1. 1 plus 7 is 8. And the 1 drops down. Cool. So I can already see 2 of these angles add up to 180. And since the other 2 sides are congruent with these 2, congruent means same, I can just add another 180. I could go plus 109 plus 71, and that works too. But hey, I'm all about working smarter, not harder. Let's be speedy here. 0 plus 0 is 0. 8 plus 8 is 16, and I'll carry that 1. 1 plus 1 plus 1 is 3. And hey, wouldn't you know it, the sum of the interior angles is yet again 360. So there is our second rule. Quadrilaterals, any shape that has 4 vertices and 4 sides. All quadrilaterals, the sum of their interior angles always adds up to 360. So on your guys' lesson 4 sheet, you can put that in right here. Triangles, the sum of the interior angles of triangles is always 180. Quadrilaterals, the sum of the interior angles is always 360. Pretty darn cool. And something else I think that is really cool is that we can see our relationship between these two numbers. We can see that 180 is half of 360, which might be kind of weird a little bit because triangles have 3 vertices and quadrilaterals have 4. Why would triangles be half? Well, check this out. 1, 2, 3, 4. Yep, this is a quadrilateral. Any quadrilateral can be split in 2, or in other words, split in half. And what do you get when you split them in half? 2 triangles. So all quadrilaterals are made up of 2 triangles. And that's why quadrilaterals are worth double the amount for the triangles. Because quadrilaterals are literally just 2 triangles put together. Check this out. This weird quadrilateral here that we talked about earlier. Check it out. Let's split it into 2 triangles. Boom. Here's a triangle, and there's a triangle. So we can see why the interior sum of a triangle would be half that of a quadrilateral. So as you guys navigate your way through assignment 4, there's going to be questions that ask you to find missing angles, okay, based on the angles they give you. So they'll give you all the angles except for 1. You're going to have to add all these angles up and subtract them off the total. So firstly, we can see on this question, is this a triangle? No, it's not. It's 1, 2, 3, 4. This is a quadrilateral. I know that all 4 angles add up to 360. So let's subtract all the ones we have off of it. And whatever we're left over, that will be X. Cool. I hope that made sense. I tried to be fast, but I also tried to be clear. Good luck. Have fun.